All right, let's get right into it. Today, we're cracking open the brain of this really fascinating global network they're calling Project Octagon. We're going to focus on one single spot up in Canada, Node 2. That's basically the command center for the entire thing. So how does this one node hold so much power? Okay, let's dive in.
The source documents use this perfect analogy to explain it. Just imagine Project Octagon is a giant fleet of ships. Well, Node 2 is the Admiral's flagship. It's not out there hauling cargo, no. It's carrying all the critical intelligence, the maps, the codes, the training manuals, everything the rest of the fleet needs to actually function and survive. It's literally the brains of the whole operation. So that leads to the big question, right? You've got all these other nodes out in the field, getting their hands dirty with heavy-duty hardware and battling the elements. Meanwhile, Node 2 is just focused on software and intelligence. So how does this brain end up being the financial engine for the entire network? Well, that's exactly what we're going to unpack. This slide just lays it out perfectly. It's the classic brawn versus brain dynamic. On one side, you've got the field nodes. That's the muscle. They're doing the heavy lifting, dealing with super high hardware costs, and just the harsh realities of the physical world. And then on the other side, you've got Node 2, the brain. It's all about that sweet, high-margin software, intelligence, and having that centralized control. It's a really stark contrast, and it's totally key to understanding how this whole thing works.
Okay, so let's break down Node 2's first major role, being the guardian of the network's logic. To stick with our analogy, this is all about protecting the ship's brain, the maps and the codes that guide that entire fleet.
At the absolute heart of this is something they call the master template. Now, this isn't just any old copy of the software. Think of it as the golden image, the one single source of truth for the entire network. This is what guarantees that a node way out in the frozen Canadian tundra is running the exact same super secure code as one that's sitting in a scorching hot desert. It's the secret to keeping everything uniform and locked down globally. So this is what that looks like in practice. Node 2 has some very specific jobs. It's the only one that can push those over-the-air updates to the whole network. It's in charge of that master template, it pulls in all the data from around the world to train its AI, and it's all led by their CTO Ash Aly, who the documents literally call the guardian of the network's logic. So yeah, he's the guy making sure the entire system stays pure. And this quote right here from Ash Aly himself just nails the whole philosophy. He says, the hardware out in the field is supposed to get dirty. It's designed to withstand the elements. But the code, that intelligence layer, it has to stay pristine. It has to be secure, and it has to be constantly evolving. It's this really clear, powerful separation of jobs that makes the whole network succeed. But here's where it gets even more interesting. Node 2's role goes way beyond just code. It's also responsible for the people who actually run the network. And that brings us to its second major function. It's a school for architects. Because think about it, a flagship doesn't just bark orders, it has to train the crew for the long voyage ahead. So how do they build this elite team? Well, the DeReticular Academy has a pretty straightforward four-step mission. First, they recruit people who already have hardware experience. Then they use this custom AI tutor to train them up. After that, they get certified as sovereign systems architects, and finally, they're empowered to go out and deploy this incredibly complex infrastructure anywhere in the world. It's basically a human scaling engine built to create this global network of experts. And let's take a closer look at the tool they're using for this, because it's pretty wild. The Tutor isn't just some training program. It's a full-on AI agent powered by a large language model. It can teach in multiple languages, but its most critical feature by far is what they call black start capability. What that means is it can operate completely offline, which is a total game changer for training people in remote, off-grid locations. Okay, so let's recap. Node 2 is a software guardian, and it's a high-tech school. But how does all of that add up to being a profit engine? That is the crucial question we are going to tackle next. All right, let's follow the money. We're diving into the high-margin profit engine. This is where we get to see exactly how all that intelligence turns into serious profit. Let's look at the numbers.
So what's the secret sauce to Node 2's profitability? It really starts with this number right here, $200,000. That's the sticker price for a single perpetual license for their core software. And notice, this isn't a subscription. It's a one-time purchase of a really high-value digital asset. And that, my friends, is where the real money is. This chart breaks it down for us perfectly. I mean, look at that. A whopping 74% of their revenue comes from those software royalties. The Academy tuition chips in another 20%, and then a small but very significant 6% comes from a pilot program in something called data arbitrage. We'll get to what that means in a minute, but for now, it's crystal clear that software is king. Now, this income statement, wow. It shows you the incredible financial power of this model. So in the pilot year, 2026, yeah, they're operating at a small loss. That's expected. But just watch what happens next. By 2027, as the network starts to scale, they're suddenly looking at a net income of almost $3 million with a 50% margin. And by 2028, that number explodes to over $10 million in profit with a nearly 60% net margin. I mean, that is the definition of explosive growth. This right here, this is what they call the software flywheel effect in action. That first year is all about investment, right? But as more and more physical nodes come online, Node 2's revenue just skyrockets. And why is that? Because the cost of selling one more software license is practically zero. They don't have to build another factory, they just push an update. The profit engine just keeps spinning faster and faster with almost no additional cost. But, and this is the real kicker, selling software isn't even the end game. The ultimate prize is something even more valuable. Let's talk about the future, data arbitrage. So what in the world is data arbitrage? It's all about cashing in on this one-of-a-kind data set that only Project Octagon is building. We're talking about a direct apples-to-apples comparison of how advanced AI and hardware perform in the real world across every climate you can possibly imagine. This is data that nobody else on Earth has, and it is incredibly valuable. This timeline just puts the entire strategy into one perfect picture. 2026 is the investment year. It's all about validation. Then, in 2027, that software flywheel kicks into high gear, profitability explodes, and they can roll out new applications like the clinic in a box. And then, by 2028, they enter the data arbitrage era, where selling this unique data becomes a pure profit stream. It's a brilliantly simple, yet incredibly powerful three-step plan. So who's lining up to buy this kind of data? Well, think about it. You've got agricultural insurers who desperately need to model climate risk. You've got tech giants like NVIDIA and Tesla who would pay a fortune to see how their expensive gear actually holds up in the real world, off-grid and in extreme conditions. And of course, climate researchers. This isn't just data, it's a goldmine for a very specific and very high-value market. So there you have it. Node 2 is the brain, providing the code that fuels this whole network's growth. Its business model is a high-margin flywheel, and its ultimate destination is to monetize the unique data it collects along the way. The code is absolutely ready to scale. The real question is, can the physical world keep up? And that, right there, is the billion-dollar question.